Okay. So I started recording. Yep. Hopefully you could see my document camera. We're making a roadmap for Unit 10. We have gotten through the gabriel, and now we're doing some review reactions, and this is reduction of nitrile. 2 H2O, and we have this. So again, I mentioned that we added a carbon. So that carbon is the sixth carbon, and then when we reduce the triple bond into a single bond, we get NH2. You see how those two are different? They're both primary amines, and you would have to make a primary amine with nitrile because there's no other R group on this nitrogen. There's only one R group. So this again is the other way to make a primary amine. Now, what about this amide reduction? How do I fit this onto a map? Because, and again, hopefully you guys are learning the skill to create your own study aids. But this one presents a little bit of a challenge because with the reduction of an amide, if I could find it, right? Oh, oh, here it is, right here. So we're going backwards. So here's your amide, and we're going to make it into an amine. In this case, I have a secondary amine. Secondary amine. So I challenge you to figure out how to put that amide reduction on this roadmap. So we could maybe start from the alkyl halide, but to make that amide, we'd have to go through a lot of steps. We would have to either make this an acid chloride, then create and use another amine, right, to make the amide, and then reduce it to make the amine. My challenge is how do I make this? So now we're going backwards. If it's really the reduction of an amide, do you know how your amide would look like? Hmm. This is why it's important that you understand how to do the reaction forward as best as possible. You want to master that because going backwards is a lot harder. Reduction of amide, it's in the language. So I need to make an amide. How would an amide look like for me to get this type of amine? Then it'd have to look like this. I know it's a weird looking amide because it has no other R group. This is called a primary amide. And then if we take this primary amide and we reduce it, LiAlH4 to H2O, to H2O, we get rid of this C double bond oxygen. And that's what lithium aluminum hydride does to amides. Okay. How do we make the amide? Okay, that's an interesting question. Um, we make an amide from, I mentioned on this previous unit, the carboxylic acid derivatives unit, that the best way to make an amide, the preferred way, is via an acid chloride and an amine. Okay, acid chloride, and the amine would be this one, NH3. Um, can we connect anything else? I think we're good. You know, there are ways to go. Are there ways to go from the alkyl halide to the acid chloride? What would you want to do? You would want to have a carboxylic acid. Okay, so let me draw that and stop right there. So you know this reaction for sure, right? SOCl2. So this is, everyone is a different map maker. Okay, so I have that. All right. Um, what about secondary amines? What's the best way to make a secondary amine? The best way to make a secondary amine is to still go through the amide and do a reduction. So let me show you how do I fit a secondary amine. Let's take this. Ah, how about this? Let's take this acid chloride and let's react it with a secondary amine. Maybe I already said secondary amine, so I meant primary amine, but let's do secondary amine. Okay. So what would the product of that be? The roadmap is getting pretty interesting. So now we have that amide. And then, again, what am I looking at? From the 30,000 foot view, I've seen how to make primary amines, right? By Gabriel, and we should write here reduction of what? Reduction of nitrile. But you may be asked to make a secondary amine on this next exam. So you make the corresponding amide secondary, or in this case, it's going to be tertiary. And then all you have to do is reduction again. So let me go this way. We'll fill in the reagents a little bit later, but since we want to compare these two molecules, I'm going to draw this molecule right underneath. And look what kind of amine I get this time. I got a tertiary amine. If I wanted a secondary amine, I would have reacted it with a primary amine. And then when I react with a primary amine, this acid chloride, then I would get a secondary amine, secondary amide. And then when I reduce the secondary amide, I get the secondary amine. But here I reacted with a secondary amine to make the tertiary amine. That was a lot. You'll go back to the video or to your notes and just make sure that you understand what my thinking is here. LiAlH4 to H2O. Okay. And that was just the first video for Unit 10. Again, I am assuming that everyone had watched the 3 videos for Unit 10. It's already Friday, that you have taken notes, and this should be review. Unit 10, the first video, we went over the gabriel, reduction of nitrile, and then this one was reduction of amide. 3 things. Not only does the act of making your own roadmap help you memorize these reactions, but because it's open notes, there it is. Okay, we summarized 30 minutes of video and maybe 2 or 3 pages of notes into one roadmap. Okay, one roadmap. I'm good with that. Let's see what video number 2 had for us. Oh, thank goodness. Okay, no more making amines. We are using amines to do these reactions. Actually, reductive amination is to make amine, but let's take care of this. What is reductive amination? Very easy. And we have an opportunity. I just want to make sure that I'm wondering if I can make a tertiary amine here. Yeah, I won't be able to do that because we go through an imine, and you can only make imines from primary amines and ammonia. But you make an amine, okay? That's the main point. And we're doing this via reductive amination. It's just one reaction. Why would this be important? Because look at my starting material, aldehyde or ketone. You notice that I have no aldehydes or ketones anywhere on the roadmap. So it's another method to make an amine if you're not given an alkyl halide, if you're not given an amide, if you're not given a nitrile. But if you're given an aldehyde or ketone, you could definitely make the amine. Now the issue is I'm showing you how to make a secondary amine. I don't have any secondary amines on the roadmap. Okay, I do have a primary amine. So let's try to make this primary amine via reductive amination. Okay, so there's your target. what reductive amination does. It takes the carbonyl group and you put the nitrogen right there. And if you want your nitrogen to have any R groups, you're adding those R groups via the amine that you're using in the reductive amination. So yes, there are three things you have to remember. The amine, this weird looking reducing agent, it almost looks like NABH4, right? Because what you're really doing is you're making the imine and you're just getting rid of that single bond. You're getting rid of the double bond to make a single bond. Where's the key carbon? Right there. So if you're trying to make, for instance, a primary amine, where does your carbonyl group go? It goes on the dot. This is the type of logic that organic chemistry is trying to train you all to do. It could, for some, it could be very complex, maybe even convoluted. But do you see my thinking here? If I want to make this amine, I noticed that the nitrogen was right where the oxygen was. So the shortcut is I just have to make a carbonyl group at the dot. Make the carbonyl group at the dot. The dot in this case is right here now. Right? Make the carbonyl group here. So that's the key. To make this primary amine via reductive amination, I need an aldehyde in this case. See how I got that? I got, reductive amination, you're not adding any carbons, so I better have the right number of carbons from the get-go. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I noticed by pattern recognition, I noticed that the nitrogen replaces the oxygen. Okay, but I could bring whatever groups I want. I don't want to bring any groups though. So what am I reacting this with? I'm reacting this with NH3. Okay. That weird looking reducing agent, NaBH3Cn. So I took NaBH4 and I replaced one of the hydrogens with a nitrile group. Sodium, not borohydride, it's sodium cyanoborohydride. Okay. They did that because it's a little more, how should I say, it's a little more soluble by putting this nitrile group. And it's not entirely necessary, but this is run under pH slightly acidic, pH 6. This is called reductive amination. This roadmap is getting more and more interesting as we go. Can you make me this, though? Okay, fine. What's a legitimate question on the exam? A legitimate question on the exam is, well, now that I know that I could replace this oxygen with any nitrogen-containing compound, I can make this into an amine. How do I make this? So now you have to fill in the green arrow. What you should be focusing on is, get rid of some of this distraction. What you should be focusing on is where's the pattern. This is a reductive amination, right? I took this carbonyl group, I made the imine, so there was a double bond right here, and then I got rid of the double bond. So ultimately, whatever this is, I'm putting it here, getting rid of the double bond, and making it neutral. I know that's a lot of steps. We didn't really go over the mechanism, but I showed you the intermediate. See, you're making an imine. If you don't know what an imine is, then, well, you didn't watch the videos. All right. So, can we fill in the green arrow? Look at the analogy here. NH3 turns to NH2. Well, I want an NH in this isopropyl group. H2N. It's all neutral, right? All neutral. We'll remove a hydrogen in one of the last steps. But all I'm doing is following my analogy or my template. NaBH3Cn, pH around 6. The key carbon is this one right here. So if you take a note card, you're adding this nitrogen to this dot and taking out eventually water. So that was your substrate or your starting material. What are you adding? You're adding this, and you're adding this as an amine, as a neutral amine. That piece right there. I'm glad I did this because in this whole roadmap, this is the only secondary amine. Now we could have made the secondary amine via reductive amination. I'm sorry, reduction of an amide by making, like for instance, if I made this amide, that would be a secondary amide, but then there's an H there, and then I reduce it to the secondary amine. All right. Okay. I know that was a lot. We do have 2 reactions still on that second video, but this one's going to be easy to put on the roadmap. It's the imine and enamine formation. So we're all starting from an aldehyde or ketone, and we're either going to add a primary amine, there's a primary amine, or secondary amine. Okay, so let me show you that. So the thing is, we're making a new product. We're making imines and enamines. So I am going to have to start like a little island here, a city onto its own. Oh, no, we have an aldehyde here. Why do we use this? You could either add a primary amine, H2N, or you could add a secondary amine, diethylamine. Okay. Is there anything else? I always worry about getting dinged because I forgot a temperature, or I forgot a acid catalyst, or I forgot heat. For these imines and enamine formations, you don't want pH a little bit acidic. So the way I wrote that is you could put HCl, or you could put pH 6, or you could put both. It doesn't matter to me. I'll just go put pH 6 for both of them. This is where naming is going to be really important. Aldehyde and ketone plus primary amine gives you imine. So the key point here is that you have a primary amine. For the other reaction, you have a secondary amine. And we'll see how that changes. So here, an imine looks like this. It's a double bond to nitrogen from carbon. Primary, we bring with it our R group. The preference is to draw the R group in the trans, because this is a double bond. We had a choice between making the R group on the right or the left. Let's put it on the right so it's less crowded. You want to make the trans. Okay? Again, your note card, blank note card. What did you add? You added this amine to where the oxygen is. So take a look at that right there. See, the bond that was made was this one right here. You can put a dot, right? You are responsible for the mechanism. I showed you the mechanism for imine formation. Why is imine so important? You won't be able to see this literally without imines because rhodopsin is an aldehyde in your eyeball hooking up with a protein opsin, to make this connection, an imine connection. When light hits rhodopsin, it will change the double bond conformation from, I always get this wrong, from from trans to cis. In the dark, you have uh, you have a cis version. When you hit it with light, it goes to trans. Pretty sure I got that mixed up. Let me double check. Bottom line is, the reason why you see and why you're able to interpret light as images is that you have this conformational difference. And let me find that picture real quick. All right, hopefully you can see that picture. Let me move some stuff out of the way. Okay, so here you have retinal, which is a form of vitamin A that got oxidized. So you eat carrots. Carrots is beta carotene. What your body does, it cuts beta carotene in half, and so this literally looks like one half of beta carotene, which is actually vitamin A. You oxidize it to the aldehyde, and this is what we're doing, right? Aldehyde plus amine. Now this protein opsin is huge, right? It's a protein. It takes up probably 3 times the screen. But that retinal molecule can find that amine and form this. Oh, there it is. A nitrogen carbon double bond. That's an imine. So the way I drew this molecule is in light. In light. I have to remember that. So when all the double bonds are trans, light is impinging on that molecule. If you close your eyes, this bond right here, this middle bond right here, that turns into a cis. That turns into a cis double bond when you're in the dark. Okay. All of these molecules, rhodopsin, I think, is the rods. Cones are different, right? The cones are, I think, perceive color, maybe, but the rods perceive light. All of those are in the photoreceptor cells that are lining the back of your eyeball, right here. Okay, it's just a little bit of coincidence, but do you see how I have a gap here? That's your blind spot, right here. So, light that impinges this area here from your eyeball, you actually don't register. Your brain doesn't know that because this is where I think the optic nerve is. Okay. So anyway, long story short, you have your imine connection right here. Let's go back to the screen. Give me 1 second. This will never be fast. Okay. All right. Hopefully you're back on my document camera. There's your imine right there. The thing is, if you react with a secondary amine, you'll have 2 R groups here. And that nitrogen, you can't put a double bond here because nitrogen will be positive, and you don't normally want charged molecules. So instead, you'll make what's called an enamine. Enamines are correctly named because you have an alkene, amine. And amine is going to be a singly bonded nitrogen. Okay? But where's the ene? Where is the alkene? The alkene is, where are we? Give me 1 second. The alkene is right here. If you look at the mechanism, why is a double bond occurring here and here? With a double bond, you have to do elimination, right? What are we eliminating? We're eliminating water. So this becomes an OH, right, after these 2 attack. And if you remove the hydrogen, beta hydrogen here, right, you make the enamine. But if you remove the hydrogen, one of the hydrogens off of the nitrogen, you make the imine. But do you see how they're both coming from the dot? That's intentional because that's where the OH group was. That's where the OH group was, right? This is called enamine. And we are done. We're done with video number 2. Video number 2 was imine, enamine, And oh, here it is, reductive amination. Okay, that's video 2 right there. All right, video 3. Video 3 is pretty important. Jose verified this was on the MCATs, the medical school entrance exam. It was on the MCATs 3 years ago, or maybe yeah, it was 3 years ago. It's not in your textbook, which was kind of weird. Actually, Gabriel is not in your textbook either, but that definitely shows up sometimes on the MCATs, and also your DATs, DAT, your pharmacy exams, your dental exams, and dental school entrance exams. So Gabriel's not in your textbook, which is weird. Strecker, Strecker is not in your textbook either. Freckler is really cool because you're making amino acids, which are the building blocks for proteins. Okay. Let me show you the Strecker. Strecker is interesting because you have 20 amino acids, natural amino acids. Okay, so hopefully you can see my screen. It's a little bit tiny, but there's 20 amino acids, natural amino acids that occur in your body, and you can make most of these via the Strecker synthesis. Some weird ones that I can't visualize how to make it from a Strecker synthesis, like this proline, because your amine is now within a ring. Okay? But what is the trick? The trick is you look at your amino acid that you want to make. For instance, let's take tyrosine. So tiny. Tyrosine. Okay. And this is your R group. The R group, they drew it off to the left. See, everything is the same except for the stuff on the left. You have to match your R group to the aldehyde you start with. So the example that I use, let me show you that, is isoleucine. There's isoleucine. Find the alpha carbon of the amino acid. That alpha carbon used to be the carbonyl. And then when you do these reactions, what are you installing? You're installing on that alpha carbon the amine and the carboxylic acid. So do you notice how this amine, this alpha carbon, is this dot right here? But eventually, look what happens to the dot. The dot picks up the NH3 plus, okay, and the carboxyl group. I mentioned on the video that really Strecker synthesis, you see a lot of times this is just NH2, but in actuality, your last reaction is acid and heat, so you would have to protonate this. So don't forget about that. So we're not making this exactly. To go from here to here, just add a little bit of base to deprotonate. But remember that key. If you're doing a Strecker synthesis, the alpha carbon of your target is actually starts out as the carbonyl carbon. Okay? I'm not going to put this on the roadmap. On the video notes, it's pretty laid out for you. You're making isoleucine. So, what I'm asking you to do in the practice problems is make a different amino acid. Okay? Not isoleucine, but I think I asked you to make phenylalanine. Phenylalanine is interesting because I used to have a really, really bad addiction to Diet Coke. And Diet Coke contains a little bit of phenylalanine. There's a good proportion of the population that cannot metabolize phenylalanine, and those people are called phenylketonuriacs. If you suffer from this, I apologize for mispronouncing it. Phenylketonuria. People who have a problem metabolizing phenylalanine. So phenylalanine, this zoom, is right there. It has this benzene ring. Sorry about the focus. We'll come out in just a bit. But yeah, sorry about that. I don't want to focus this or he'll get out of focus. Your alpha carbon is right there where my pen is pointing. So your aldehyde has to have your carbonyl group right there off of that carbon. And then you do your normal freckler synthesis. So Strecker is doing what? It's first making the imine, right, at this position. Remember we did that before? You just replace this with an N, double bond. But when the nitrile comes in and attacks, that turns into a single bond, which I have now here. That nitrile, you could hydrolyze to the carboxylic acid. So the nitrile part was here, CN. We take off the N and we make this a carboxylic acid. The nitriles are derivatives of carboxylic acid. So when you hydrolyze a derivative of a carboxylic acid, you are told that, or you know that you get the carboxylic acid back. Okay? That problem is right here. Show how to make racemic phenylalanine by the structure synthesis. I did mention that you're making racemic amino acids on the video. That is misspelled, unfortunately. Phenylalanine. Amino acid that's used in Diet Coke. Not sure why it's there. But people who are phenylketonuriacs or suffer from phenylketonuria, they have trouble processing this. And there's actually a warning if you look at your can of Diet Coke. The second problem is like an isomer problem. I give you a molecular formula and you draw me, it looks like an amino acid, but it's a specific type of amino acid. It's a beta amino acid. The beta means that the amine part is off of a beta carbon. So this is alpha amino acids because the amino part is off of the alpha carbon. How do I know this is the alpha? You're using the carboxylic acid as your home base. Alpha, beta, gamma, delta. So this is alpha relative to the carboxyl group. If you want to make a beta amino acid, just shift this dude to the beta carbon. Okay, get rid of this. Okay, and that's the beta amino acid. Very, very interesting field. Your enzymes cannot recognize typically beta amino acids. So if you want to make a drug that's based on peptide chemistry, if you make the drug out of alpha amino acids, it's likely that your body will hydrolyze that drug. It will recognize it as foreign, and there are enzymes that break up alpha amino acids. So the trick is what pharmaceutical companies are doing is they're taking a very good drug, but doesn't last very long in your body because it's digested very easily, and they're converting all the amino acid parts, alpha amino acids, into beta amino acids. Because again, your body has no enzymes that recognize beta amino acids. So if you make a drug based on that type of molecule, you can have lower dosage. The drug will last longer in your system, so it's almost like a slow time release effect, right? You're not going to process it and expel it immediately. That's horrible. You pay however many dollars for a drug and you excrete it. It's out of your urine immediately. You don't want that happening. You want it to last a while in your bloodstream. You do that by making a drug that cannot be recognized by your natural enzymes. So you're using, in this case, a beta amino acid. Okay. Okay. Okie dokie. So that is a roadmap and a bunch of stuff about amines. You know that you have a third chapter or third unit, which is unit 12. Okay. Um, and this is not great that everyone's not here, but let me show you your extra credit. And then I could open up the floor to questions because I'm basically done with what I want to talk about. Okay. I haven't talked about unit 12, which is dienes. I'm giving you one more day to try to get those notes in. Let's go to Moodle and show you what is. Oh, Before I get to Moodle, let me tell you what I am going to do, and then you can tell me what you're going to do in the next couple days. My tasks, this is just to remind me what I need to do for you guys in the next 1 or 2 days. My tasks. Number one, um, put up the Unit 12 problems. Okay, and I want to do that, write this in pink. I'm going to do this between 12 and 2 today. Number two, put up answers. So this is a pretty big endeavor for me. So I'm going to give myself from 2 to 4:30. I'm hoping to post those before 5 o'clock today. Number three, I'm going to start tabulating extra credit. Right now, no one, I don't think, has extra credit because I haven't given you anything yet. Start tabulating extra credit. Maybe that's between 4:30 and 5:30 today. Number four, talk to Jose. Ask him how you guys are doing in office hours. I think he's available. I hope he's available. 5:30 to 6:30. Number five, I need a break. I don't know if you were up late last night, but Taylor Swift released her new album last night. I ran through it once, what, 3 times last night. So I'm gonna find a nice spot to listen to Tay Tay. That's gonna be from 6:30 to 8. I'll give myself more than an hour for that. Number six. What else do I need to do for you guys? I will start looking at the forum, see if there's any questions that I can answer. 8 to 9 tonight. All the while I'm checking my email to see if anyone wants to meet this weekend. Those are my tasks. Maybe I could start making the exam also. That'll be much later. Probably 11 tonight. Give myself an hour for some of that. Okay, those are my tasks. So if you're waiting for the answers, 4:30. If you handed in any extra credit, I'll start looking at that. If you still need to meet Jose, okay, I'll talk to him definitely today, tomorrow, and Sunday, just to make sure that people are going to his office hours. So those are my tasks. I want you to show me what you're going to do the way that I showed you. Your task and the time that you plan to do this. Now, let me just go back. So this is what I expect. I need a list from you. Yeah, probably by task number 1, I'll be behind schedule. Okay, so this is under really the best conditions. If I have no interruptions, if I find time to eat, okay, if the cat doesn't bother me, this is my plan. The plan is going to go off the rails probably within the next hour. Don't worry about it, okay? Just adjust. But I really need to get these tasks done. Okay, whether I get them done in the amount of time that I said I would, that's very unlikely. But at least I have a list. I need, or I want you to have a list as well. And let's go to Moodle. The best way that you could add points, easy points, to your exam is look at Friday. Submit, submit, submit. Extra credit, extra credit, extra credit. The due dates are coming up quick, but these are easy things to do, and they're put in chronological order. By noon today, okay, we're going to be done by 11. Get started if you haven't. I'm very anal retentive, as you can tell. Maybe you are too, and you already have this list. But make me a task list, 10. At least the top 10 things you want to do and the times you think you're going to do them. You could go through Saturday and Sunday. If you don't want to do anything today, perfectly fine, okay? But try to have a plan for this weekend. Submit that so I could take a look at it. Maybe I'll give you some suggestions, but really I just want to force you to start thinking ahead. We have, 72 hours before our exam? Start thinking ahead and make that list. There are no late submissions. So at noon, that submission link is going to close. So again, we're ending early. Make me a list, either type it out or write it out, but make sure it's a PDF. The next thing that's due is the 2 problems for Unit 10. This is due today. This is the structure synthesis, the last thing I talked about, and the beta amino acids. I basically gave you the answers for these 2 problems. I want this in by 4 o'clock today, because if you saw my list, I'm going to put up answers by 4:30, hopefully. So I want these answers before I put up the answer keys. That's 4 points extra credit. If you feel like you don't want to do it, that's your prerogative. But really, you could get partial credit. I literally gave you the answers. And this is being recorded, so you could always go back to the recording if you want. But again, 4 o'clock today. All right? Maybe you could do this in 30 minutes, easily, by 11:30. Number 3, I thought I was going to give you an in-class problem, but I think it's more important that everyone know what Unit 12 is about before tomorrow. So this is a notes check. There are only 3 videos. There are 3 videos, okay? Those videos are they are on conjugated dienes, double bonds that are conjugated. So if I could get this to work, what's wrong with my webpage? It's these 2 videos. There's no cartoon. I ran out of steam. I don't know what to draw. I don't know what to illustrate for these conjugated pi systems. So it's these 3. Those are your notes that I want to see by when? By Saturday, 10 a.m. in the morning. That way, and this is for the 5 points for the notes check. So that way I know that hopefully all of you are ready to go to talk about all the units, Unit 9, 10, and 12, by tomorrow morning. Okay, and then we could start looking at the forum, start having office hours, start meeting as you and your study partner, etc. Talk to Jose, etc. The last 4 extra credit points by Sunday noon. If you want to put up a question or comment, if you get 4 of those up on the forum. So the forum now is down here. So everything that's due and everything that you can do right now to help your score is under Friday. Okay. There's a total of 12 extra credit points, 4 plus 4 plus 4, and this is right. This is mandatory, right? These are your note checks. You have them twice a week. Okay, so this is for Unit 12 though. Okay, Unit 12. Let me put up the chat. If you have any questions, raise your hand, or if you want, you could type it into chat. I have that visible on my screen. This is being recorded, so if you write something on chat, it will show up on the recording. Are there any questions or any comments about what we talked about today? Nothing. Let me think real quick. Office hours. Oh, there's a review on Sunday. I don't know if did I write that down somewhere? I didn't write it down on the announcements. Um, if you want to meet me or Jose Saturday or Sunday, just email us. We're pretty free, and the review will be Sunday at 4. And I'll either write that somewhere or I'll remind you by email. Okay, so again, go back to Friday. These are things you could do. The time I have right now is 10:54. Okay, so in within almost within an hour, get me this extra credit, this task list, and then by 4 o'clock, get me the answers to these two problems, and I'll post the answers at 4:30. Okay. Great. If there are no questions, I'll let you guys go. Go ahead and leave the room. If you have any questions after you leave the room, just email me. Okay? I'll see you guys later.